Recently, the ByteDance's team has developed a new character consistency model called Lynx. This model can elevate the character consistency in AI videos to a new level. I have conducted extensive testing on this model, and the final result is that I must admit, this model is currently the best one in the video domain for maintaining character consistency. So, how does it achieve this? We can see some technical details on its GitHub homepage. To ensure high character consistency in AI videos, it uses two adapters. One is called ID adapter, and the other is called reference adapter. You might find these two names quite familiar because we widely use a technology called IP adapter in earlier text-to-image models. The IP adapter ensures the consistency of the character style and even their facial features in terms of principles. The two adapters we are discussing here should be consistent with the IP adapter. Among these two adapters, the ID adapter primarily focuses on the character's facial features and uses the arcface format for identification. For this purpose, the ByteDance's team also specially developed a sampling model. The reference adapter, on the other hand, mainly operates in the latent space, the dense vector after VAE encoding, to freeze relevant facial feature information. Furthermore, we can see that this model is currently implemented based on 1.2.1. It offers two versions, a full version and a light version. Currently, Kijai has integrated this model into its Wanna video extension. If you need to use this model within ComfyUI, you only need to update the extension to the latest version. Then you can find the corresponding example workflow within this extension. Download it and start using it in your ComfyUI environment. Next is the model download. You can find the corresponding model in Kijai's Hugging Face repository. Note that this model is implemented based on the 1.2.1.14b base model. Therefore, the other models are connected to this main model as external plugins or external modules. As we mentioned earlier, the available versions are full and light, and there are two crucial adapters, the ID adapter and the reference adapter. Be careful when you download, whether intentionally or not by Kijai. The ID adapter is labeled as IP. The versions provided for the IP adapter include both full and light. However, for the reference adapter, only a full version is currently available. In addition, you also need to download a resampler, which is the sampling model. We mentioned this earlier. Its main function is to convert the facial feature information into arcface facial vectors. After completing these two basic steps, you can start using the Lynx model in ComfyUI. For easier demonstration, I have also built the workflow on RunningHub. You can access this platform via runningHub.ai in the ComfyUI ecosystem. RunningHub is an excellent online working platform because whenever new technologies or extensions emerge, it keeps up immediately. You can register for RunningHub using the invitation link in the video description. This grants you 1,000 free credits. Additionally, you receive 100 bonus credits every day you log into RunningHub. This allows you to test your own workflows. The workflow you are currently seeing is essentially a reconstruction I performed based on Kijai's original workflow. Broadly, it can be divided into 4 parts. First is the model loading. Second is the processing of the reference images. The most crucial part is the third section, the generation of the Lynx embed vectors. The fourth part is the sampling process. Let's look at them one by one. First, the loading of the main model. As I clearly stated earlier, our main model uses the 1.2.1 T2v14b model. The two Lynx models are loaded as external modules. Therefore, we will use a node called Wanna Video Extra Model Select. Here, we will load two patches, or two modules, the ID adapter and the reference adapter. We encountered a slight issue when loading them here. Please note that I am using the light version when loading the ID adapter, and I am using the full version when loading the reference adapter. Kijai provided an explanation for this, stating that, theoretically, loading the full version should yield better results. However, for some unknown reason, it consistently produces errors when loading the full version. Consequently, the consistency actually becomes weaker. Kijai found through testing that the combination of the light version and the full version yields better results than using the full version for both. Therefore, we will temporarily use this combined method for loading. Afterwards, we connect this output to the extra model to inject it into our main model. Similarly, we utilize an acceleration model here. We also use a reward LoRa. Note that I am using the MPS LoRa here. Kijai's original workflow might use the HPS LoRa. I believe the impact is not very significant. Pay attention to the weight. It is set to 0.5, not the full 1.0. At the same time, we have enabled block swapping. Then, we apply both the block swapping and the LoRa to the main model and save it. We also load the VAE. Next, we load a sampler. This sampler is the model we just downloaded. Its main role is to convert our facial information into the specialized variables of the ArcFace form. Now, let's look at the reference image processing section. We have a reference image. Take a look. It is a very beautiful Western woman. We then pass it through a very important node called Lynx Inside Face Crop. This extracts the IP image and our reference image. Note the difference between the two. The IP image focuses only on facial information and is smaller. The reference image, however, focuses more on overall characteristics, so the image itself is larger. We then save them. After saving, these images will be used to generate the corresponding Lynx vectors. First, let's look at creating an empty latent space vector. We set the resolution here to 832 by 480 and the frame count to 81 frames. Next, let's see how we use this facial information. First, we use the sampling model we just mentioned to encode the ID image. Next is our reference image. The reference image primarily works in the latent space to freeze facial feature information. Therefore, it works together with our VAA and is directly connected to the reference image node. Then we have a prompt here, which reads image of a face. There is also an explanation here, stating clearly that this is a hard-coded format. What does hard-coded mean? It means this prompt is fixed, so you don't need to worry about this section when using it. Just leave it written as it is. Then we move through a node whose name is also quite interesting. Want a video add Lynx embed. From the name, we can see that it essentially adds the Lynx vector to our latent space. So we take an empty latent space and combine it with our conditional feature vectors to ultimately generate the required image embed before moving into the sampling phase. The sampling environment itself is not particularly complex. We take our image embed and the model. There is a prompt here, which then goes through our sampler. Note the sampler settings. We are using 6 sampling steps. The CFG is set to 1.0. Note that the sampler used here is LCM. This is slightly different from the sampler settings in Kijai's other example workflows. After that, we perform decoding and we get this result. This shows a beautiful woman sitting on a ruin, reading a book with a very cute mutated animal beside her. First, let's look. The character consistency is maintained extremely well. I also ran many tests here. For example, let's look at this one, a beautiful woman walking through a ruin, holding a flashlight. However, you should note that when generating the video, it is heavily influenced by the reference image. For instance, I wrote a prompt for a dim environment here, but the resulting environment is still relatively bright. If you are creating conventional videos, this is not an issue. For example, let's look at her playing the guitar and singing. The consistency is excellent, and the movements are fine. We can make the description more complex. This is inside an abandoned warehouse, and she is holding an oil lamp. This also works fine, but have you noticed something through these examples? Her facial direction always seems to be oriented in the same way. For example, this scene, this one, the beautiful woman in the ruins we mentioned, and the guitar scene, this means the facial orientation is almost entirely influenced by the reference image. This is a major issue I discovered during my tests. Furthermore, its ability for complex composition is not strong. For instance, I tested this scenario, an astronaut in space. I wanted to see the image of the blue Earth through the spaceship window, but you can see that the overall composition is very strange. Therefore, when the video composition is complex, this model cannot render it very well. Additionally, it also sacrifices action performance to a certain extent. Let's look at a scenario we previously tested, the beautiful woman kicking open a door. Overall, the video quality is quite high. However, you will find that the action lacks dynamism. It doesn't have the same impact as when we tested it using other models. I also tested some complex actions, and this one is clearly unrealistic. Such action performance inherently has issues. Furthermore, consider this scene. The door opens, and the beautiful woman lies prone on the ground. Notice that this movement is also very strange, although the overall action is rendered. You will find that in terms of both rationality and aesthetics, it cannot compare with WANA 2.1. Through these example tests, we can conclude the biggest advantage of this model is the improvement in character consistency. However, its shortcomings are also evident. It does sacrifice some of the compositional capabilities of WANA 2.1 and its ability to display complex actions. No model is universal, it only matters what scenes it is suitable for. If you feel that your video generation requires extremely high character consistency, then you can consider using this model. That is all for today. Follow me to become AI savvy.